Hello and welcome. This video is specifically for Tech 4474 and covers how to implement the Move Until tag in the Yaskawa YRC 1000 controller as it applies to the robots in our lab. As discussed in this class, because we don't have a PFL board in our GP8, we have developed a workaround that uses the robot monitoring functionality that comes standard on the controllers. This video will allow you to program the robot to start a move, and if there's an interference or obstacle that results from the move, using the Move Until tag will allow you to force the robot to stop moving before a collision is actually detected. It should be noted that this is not the preferred or recommended way to do this, and that by doing this we are potentially risking the life and functionality of the robots. Yaskawa has not endorsed this solution, and doing things this way should be done with full understanding of those implications. So, the Move Until tag that is available for all the move instructions will allow the robot to react to an input while in motion, allowing the robot to stop motion and to do something else if the input is triggered. What you see here are the three menu areas that are a part of this. On the left is the job. Notice that line 4 has the Until tag attached, and that is looking to see if input 313 is on. This is because that is where I have mapped the outputs from the robot monitor logic, which we will see later. In the upper right corner is the input state, and the lower right corner are the current disturbance levels from the shock sense level menu option. Before we get started, you will want to change your security level to management, or you won't be able to do everything. So to get to the shock sense level menu, select Robot and Shock Sense LV from the menu on the right. As you can see from the video I took in the lab, as a robot starts to press on an object that is in the motion path, some of the max disturbance levels for some of the joints will increase. You will need to test the system a few times to ensure that you're getting good values for the max disturbance. To clear the max values, select Data from the upper menu and click on Clear Data. Once you have an idea of what disturbance levels are associated with your desired level of interference, you will need to go to the second or possibly third menu screen on the left by pressing the right arrow at the bottom of the screen. You'll be looking for the PM Preventative Maintenance button. Press that and then select Robot Monitor. Select the item to be monitored. Select the item to be monitored. On our robots, it defaults to torque. Select or arrow to torque, or whatever your robot is currently showing, and change it to disturb. Arrow down to the joint that you want to set and change your desired setting. You will then want to test the system at various settings, starting low and gradually increasing the value, as there's not a direct correlation between the detected disturbance level and the percentage value shown here. I chose 10% as an arbitrary start point. You may want to start lower because you want to make sure you're protecting both the robot and your tooling. Change the output to either 9 or 10. Repeat the process for the second joint, or set the percentage value to 0 to clear it. If you need to react to more than 2 joints, please see me. To test the system, go to General Purpose Inputs and monitor input 313. When you have pressed enough, but not too much, with the robot, you should see the input turn on. If you feel that the robot is pressing too hard, such as you see the table starting to actually bow, go back and lower that percentage value. Also, and this is important, you will want to make sure that you're going slow when you do this. If you move too fast, you will not only likely trigger a collision, but as the robot goes faster, the perceived disturbance levels will be higher, which once again will most likely result in triggering an actual collision occurrence and may break your end effector or the parts or even potentially the robot. So go slow, start small, and only ramp up a little bit if you need to. Once you're satisfied with the level, go into your job and modify the move instruction that will benefit from the Until tag. Make sure you're on the instruction side of the screen, press select so that the instruction is highlighted in the edit buffer, and then press select again to get to the detail edit. Arrow down to the Until tag and press select. Pick Until and then update the tag's details so that the input being monitored is 313. Press enter 3 times so that the update is reflected in the instruction in your job. Now you can test your job. Remember, you need to set the speed to be a fairly slow one, probably well below 20 millimeters per second, and as you can see on the screen, I have my robot set to 5 millimeters per second. My job is pretty simple. It moves from a start position to a finish position that is partway below the height of 2 of the plastic parts. If the robot is able to make it to the second command position, the one with the until tag, then it'll move on to a third position. If, however, the robot encounters an obstruction, it will move back up to the top of the job and at the try label and will attempt to move again. Please note that the line immediately after the until tag line, which is line 4, has the conditional jump in that if it sees that the input is true, it will jump back up, but if the input is false, it will allow the job to continue. So hopefully this makes sense. Thanks for watching.